All right, let's take a look. See how you did on these. Like I said, hopefully these didn't take you too long to figure out. We've worked with these properties quite a bit over the last week or so, but so if we take a look, like I said, I want you to either mark them as correct or wrong and then fix the ones that are wrong. How about the first one? Is that one correct or wrong? What do you think? What's the answer? Sophia, help me out here. Correct or wrong on the first one? Okay, it is wrong, and therefore, what's wrong with it? How do I fix it?
It should be log A minus log 2.
Okay, yeah, when we are dividing in the argument, the property is, we then, remember, division and subtraction go together. So number one is, this one is wrong. This should be the log of A minus the log of 2. Okay, log of A minus the log of 2 is what you should have. Okay, so this is not correct. That actually is, they kind of took the change of base formula along with the idea of dividing and trying to kind of put them all together a little bit and confuse you. How about number 2? Correct or wrong on number 2? Wait, Connor, help me out. What do you think?
I said wrong.
Okay, and why? How do we fix this? What's wrong with it?
It should be like A times B times C.
Perfect. Yep. When you add the 3 logs together, that means we multiply the 3 arguments. When we combine those, when we condense into one log, instead of addition, these should be multiplication instead. A times B times C in the argument. Good. How about number 3? How about number 3? Correct or wrong? What do we think? Elias, what do you think?
Correct.
Okay. Yeah. This is one of your properties. Anytime you take the log of something raised to a power, you can always bring that power up front. Okay. So this one is actually, that one's correct. How about number 4? How about number 4? Correct or wrong on this one?
Wrong.
Wrong? Okay. Why?
Because since they're subtracting each other, you're supposed to divide it.
Okay. Yep. Exactly. This is basically the exact opposite of number 1. Number 1, we had division and we expanded it to subtraction. Number 4, we've got subtraction and therefore we're condensing it to division. Okay. So this one's more of a condensed type of problem. So what you should have instead of this is this should equal the log of n over 1, okay, or just the log of n, okay? So that becomes division. How about number 5? Correct or wrong on this one? What do you think? How about number 5? Logan, what do you think? Do you think that one's correct or do you think it's wrong?
Wrong.
Okay, why?
I have no clue. It just looks wrong.
Okay, it just looks wrong. Anybody else? Correct, wrong? Cal, help me out.
I said correct.
Okay, why correct?
Just because, like, they're both 2 to the nth power.
Okay, yeah, so this actually takes a couple of steps. It is correct. This one is actually correct. Okay, and here's why. If you take the power and you bring it out front, what you actually have then is, I'm going to kind of put this off to the side, you have n times the log base 2 of 2. And what's the log base 2 of 2? 1. N times 1 is n. Okay, so it uses the property where you bring the exponent out front, and then they actually evaluated the log base 2 of 2 as 1, and therefore it is n. Okay, so that's where that's coming from. And then finally, how about number 6? Correct or wrong on number 6? What do you think? This one, Devin, what do you think on this one? Yeah, this one is correct. You can put the 2, when the number's up front, you can put it back in as an exponent, okay? And therefore you're squaring the quantity AB, which one of our properties from the last chapter, remember, means you can then square the A, square the B, and then split it up as addition since we're multiplying. So that one, there's a lot going on, but it's all correct, okay? And the only reason I put the part down here in blue, to find the log base B of -1 without a calculator, is just as a quick refresher, quick reminder, because what's the answer? What's the log of -1? Regardless of what base. What is it, Monica? Don't overthink this one. It is no solution. Just reminding you that you cannot take the log of a negative number. There is no value of b, there's no base that I can raise to a power and get -1. Because remember, your base has to start off being positive. That's part of the definition. So in this case, this one is no solution. And that goes directly with what we've been working on the On the logarithmic equations, anytime you're solving a logarithmic equation, that's why you always have to check the answers to see if there's any extraneous solutions, because the argument, the domain of a log is limited to have to be positive. Okay, so you always have to check to go back. That's kind of the reasoning behind it. All right, let's get into the actual notes. So just a couple of reminders here first as we're closing out the chapter. Okay, we spent a couple of days talking about exponential equations. So remember, really two things that you're doing with exponential equations. If you can get to have common bases, reduce them down so that you end up with a common base, and then you can set the exponents equal and go from there. Anytime you've got an exponential equation, that's kind of the first thing you want to look for. If you can do that, that's usually the easiest way to do it. If not, then we said solve for the exponential part and use logarithms, definition of a log, to go through and solve that. Change it to exponential or change it to logarithmic form. Notice I put a 3 on here now, okay? Because the only extra thing is if it's base e, if it's e to some e to the x power, or e to the 2x power, or something like that, rather than 5 to the 2x, or 7 to the 2x, or whatever it might be, if it's base e, the only thing that happens that's different is instead of using logarithms, we'll use natural logarithms, because natural logarithms are base e. Okay, so we'll go back and we'll talk some more about that, but that's the only difference if you're dealing with a base e exponential function. Okay, use natural logarithms to solve. Then we went to solving logarithmic equations, and so reminder again, usually one of three things is going to happen anytime you've got a log in the equation. Number one, if two logs are equal, remember their arguments then, it's kind of common, I called that kind of the common sense idea. If two logs are equal, that means their arguments are equal. Okay, just set whatever the arguments are equal to each other and solve. Don't forget to check extraneous solutions. Number two is basically if you've only got one log in the problem, just like an exponential function, solve for the log, and then from there, change it into exponential form and solve. Okay? Just like when you did exponential, solve for the exponential and change it into logarithmic. Same idea. And finally, number three, if there's more than one log on a side of the equation, you're going to have to do some condensing first, and then one of the first two problems. Okay? So some things, just a refresher. Let me give you an example. Here's kind of an example right here. So if we take a look at example 1 in your notes, first question I have for you, is this an exponential or a logarithmic function? Exponential, why, William?
Because there's no log.
Yeah, there's no one, there's no log or natural log or anything that's written in the problem. And two, more importantly, there's a variable in the exponent. That's what makes it an exponential function. Okay? So, if we go through and we follow this, we're gonna solve this the same way we've been solving all the other exponential functions. And that is get the exponential part by itself first. Meaning, I need to get that by itself before I can do anything else. So step number 1, we're going to subtract the 6 over to the other side. So we have e to the 3x power equal to 4. And now, normally what would you do? What if that was not an e? What if that was some other number? What would you do at this point?
Divide.
Not divide, because it's not e times 3x, it's e to the 3x power.
Square root.
Not square root, nope, because it's not being squared. What's the opposite of what have we been working on here? What's the opposite of an exponential?
Log.
We would normally change that now into logarithmic form. Okay? So the whole point of getting it by itself is so that then you could change it to logarithmic form. So I'm going to do that in two different ways just so you can see it. So if I change that, this would be the log base e of 4 equal to 3x. If you change it into exponential form, into logarithmic form, excuse me. That's one way that you could write it. And I'll actually show you a couple of options for this one again, just as a refresher. One of the things to remember, though, is the log base e, remember, that is just what's called a natural log. Okay? That's by definition, a natural log is a log base e. So really what this actually says is you're taking the natural log of 4 equal to 3x. Because a natural log, this log base e written as the natural log of 4 is exactly the same thing. Okay? Natural logs are log base e. So it's the exact same thing. And now what's the only step left to solve for x? Now we do it. Logan, now what do I do? Call him any because he had it before.
Oh. What did I say?
Now we divide. Divide both sides by the 3 to get x by itself. And now you can type that into the calculator. Type in the natural log of 4. Divide it by 3. And what do you get for this one out of curiosity? Let's take a look. Let's pull up the calculator. So notice there's your ln button right there. Okay? So you can see that that's there. So we've got the natural log of 4, and then I can go through and divide that by 3, and there's my answer. It's approximately 0.46. We'll just round to the hundredth place. One other thing that I'll show you again, I think you can plug in log base e as well. Okay, I think you can plug it in the other way. Let me clear this out of here. Let me just check. So if we type this in as log base, I think there's just a regular e on here, isn't there? Not that one though. Maybe not. I thought there was. No, maybe not. I thought there was just a regular e, but not this e that's up here at the top. Okay, not this one is not that's more scientific notation is what that is. So, but the lowercase, I thought there was just a regular e on here, and apparently there isn't. So when you're dealing with logarithms of base e, you're going to need to use your natural logarithm button. Okay, meaning you have to recognize that this is the same thing as that. Okay, you just have to recognize the same thing. So we ended up, what did I say, 0.46? And there's our final answer there. Any questions? Anything not make sense before we move on? Any questions you have before we get going here? All right, let's do another one. So example number 2. So in this scenario, this one we're looking at a logarithmic equation. Okay, it's got the natural, as a matter of fact, it's a natural log equation. But we started off the same way that we started off the last one. There's only one log. Okay, I don't have 2 equal logs, so I can't set arguments equal. I don't have more than 1 log, so I don't need to do any condensing. So it's just like what we just did. We're going to go through and get the log, the term that's got the log in it. We're going to solve for that first. So add the 3 to the other side is the very first step. Get that out of there. So we have the natural log of x equal to 8. And now, in this case, now we're ready to go back to exponential form. Okay? So just like we did before, we got the exponent by itself and went to logarithmic. Here we got the log by itself, and we go to exponential. So if we change this into exponential form, remember you always start with the base. When you see a natural log, all you have to remember is that it's base e. Okay? So we would have e raised to the 8th power, and that equals x. E to the 8th power equals x if you go. And now that x is already by itself, you can just type in e to the 8th power right into your calculator, and you've got an answer for that. There's your e raised to the 8th power. Our answer is 2,980.96. Or if you'd rather leave it as e to the 8th power, that's fine too. You can leave it that way as well. How we doing? Questions at all? Doing okay on the idea of natural logs and e? Like I said, it's the one thing we haven't spent a lot of time on yet, but it's just a very minimal difference. Last one I want you to try. Last one we're going to go through, and then we'll wrap this up, and then I'll kind of tell you where I want you to go from here. Okay. First thing to notice, we're dealing with a logarithmic equation. And so what do I do on this one? What do I do?
You divide both of them? Or
Not divide, but I think you have the right idea.
They're already equal.
Yeah, this is one where you've got 2 logs that are equal, right? Even though they're natural logs, it's still logs. 2 logs are equal, therefore set the arguments equal to each other. Okay? Take the 2x plus 1, set it equal to the x minus 4, and solve. Okay, when two logs are equal, set this, and again, that's kind of why I say this is the common sense one. When logs are equal, arguments are equal. Just drop the logs out of there and go. So we'll subtract the x over here to the left-hand side, which means I'm going to subtract the 1 over here to the right-hand side, and we end up with x equal to negative 5. But, and I actually forgot about this on the last one. We'll go back in a second. But remember, we need to check. We got to go back and make sure that we got to plug this back in and check for extraneous solutions anytime we're solving a logarithmic equation. Because the argument has to be positive, is my answer negative 5, or do I have no solutions to this problem? What do you think? Jack, what do you think? Negative 5 or no solution? If I plug that back in, is it extraneous or not? Not sure? Somebody help him out. Claire, help him out a little bit.
It's not extraneous.
It's not extraneous, is that what you said? Okay. Agreed? Not extraneous? Yes? I see yes and no. Uh-oh.
Isn't that, extraneous is where they both equal the same number?
So that's what you're checking for, is you're checking to see if, there's a couple of things. You're checking when you plug it back in to see if it's a true statement. But when we're dealing with logs, more so than that, because if you plug that back in, you're going to get negative 9 in both spots, right? So if you do get the same number, what's the problem though with not having negative 9 as that number?
That's positive.
Can't take. That's why in the warm-up you can't take the log of a negative number. So in this case, really what you're checking for with logarithms is do you, when you plug it back in, do you have a positive argument? Okay. Will the argument, in this case, like the x minus 4, I'm going to get a negative 9. I can't take the natural log of a negative 9. It doesn't work out. Same thing over here. I can't take that. It doesn't work out. So this one does turn out that this is extraneous. And therefore, since that's the only possible answer, and it's extraneous, the answer to this problem is no solution. There is no actual solution to this problem, because the only one that actually gets those equal doesn't work. Like I said, I was so focused on the natural log part that I forgot to go back and check extraneous here, not on example 2. Is this one extraneous or not? This one should be quick. If you plug that one back in, no. You just plug it right back in, you got a positive almost 3,000 as a number, and therefore you can take the log of that. So that one does work out. Okay? So here's where you're at for today and moving forward. Wanted to basically get you into the E in the natural log so you're understanding that. Okay? You have, if you're still working on the previous assignments, any of the solving exponential equations worksheet, solving logarithmic equations worksheet, the 7-5 reteaching worksheet. Remember, you need to ultimately get both sides done. Okay? I split that into 2 parts though over the last week. And then the last one that I gave you was the solving exponential and logarithmic equations worksheet. Okay? That one you picked up the other day. Some people may have started it, and actually some people already completed it. A lot of people I think picked it up, but maybe did not get to it yet the other day. If you were not here, I do have it. If you need it, I can grab you one. Otherwise, like I said, the other sheet that I had you pick up today is the review that you can start taking a look at for the test. And again, yesterday I put together an answer key for this. So every worksheet for the whole chapter is out there. You can take a look. Okay. This is not an assignment, but it does a really good job of taking you back through a little bit of everything that we've talked about. Okay. All right, I'm going to give you some time to work, ask some questions, and we'll see where we're at. Oh, notice too, by the way, some people I started calling, quick heads up, kind of on ELTs going forward for the final month of the school year here. I kind of made a decision over the last week. I started putting some people in yesterday. Mainly I started putting in people that if you're failing right now, okay, obviously I want to try to make sure that you don't end up failing. Okay, so I started putting those people in. Now, if you've completely been caught up this chapter and it's been a really good chapter, well then I didn't bother because I thought, you know what, you've been doing a really good job. You've been working hard in the class. You're probably doing okay. Okay, the failing grade might be coming from before that. But otherwise, if you need to come in or you want to come in because you have questions, either just go out to my Canvas page, and remember the link is out there, you can sign yourself up, or just let me know and I'll bring you in. But otherwise, I'm gonna kind of get to the point at the end of the year where I want you to take the responsibility, not I have to call you in because you're not doing your work, okay? So I want you to take that responsibility. So just a heads up on that. All right, let's go to work.